Dear students, good morning, namaste. This is three-dimensional geometry. We are in part 2 already. In the part 1, we discussed about the octants and coordinates of a point which is in the first octant, and also we find the distance of OP, the distance of any point from origin is OP, that is x square plus y square plus z square with root. Okay. And also we discussed about the direction cosines. Direction cosines means, once again we repeat, direction cosines means the same diagram. P is a point in the space that OP makes angles alpha, beta, gamma with the x, y, z axis. Then cos alpha, direction cosines or it is cos alpha, cos beta, cos gamma. Okay, now which are simply L, M, N. Don't put it in a bracket. DCs or DRs. These are called as DCs. We know it well. Now, you see, a very good concept. Cos alpha in the diagram, this one take. Already we discussed it is also 90 degrees. O to A, origin to A. OP is there, Nana. OP, OA, AP. AP is a diagram in this wall. AP, OP. This is also right angle triangle. It is difficult to imagine, but you have to imagine like that way. So here also cos alpha means it's a 90 degrees. In the diagram you observe it. In the diagram all other ways are right. In the triangle OAP, the triangle OAP, cos alpha is adjacent side OA and hypotenuse OP. OA is x, we know it. OP is r length. Already we discussed. So this is L, the x by r. Okay, that is x is equal to L r. Okay, similarly, now need to draw the diagram. That is OP is there, BP is there, OB, O to B on y axis, B to P is the diagonal of that wall, OP. It is also 90 degrees. So very simply, cos beta is equal to x, not x, that is related by r. That implies cos beta is m, so m is equal to y by r. That implies y is equal to mr. Okay, na? Y is equal to m by r. This is one thing, it is y. Similarly, cos gamma is z by r. That implies it is n is equal to z by r. That implies z is equal to nr. Okay, na? Right. Now, observe. Now, what is x square plus, just wait. What is x square plus y square plus z square? We write r square. The distance are simply, you write first. This is the distance of point, or otherwise OP also. That implies x square plus y square plus z square is equal to r square. Okay, na? What is x square from that one? It is l square, r square. It is m square, r square. It is n square, r square. That boxes are there. Is equal to r square. So r square is taken as common. It is L square plus m square plus n square is equal to r square. Will you agree? So, what is L square plus m square plus n square is equal to r square cancels, we get 1. A fantastic concept. L square plus m square plus n square is equal to 1. The sum of squares of DCs of any line, not OP or OQ or OR, whatever it may be. If a line means, this is a line segment. A line means, no doubt it makes some angle. It's not necessary. It is from horizon. Suppose in the space some line is there. It is not connected with the horizon. Even though parallel to that line, if you draw through O, another line which is parallel, that is nothing but make some angle alpha with x, y, beta with y axis, gamma with z axis. That means the parallel lines, original line is this one, through parallel to the original line, we are taking another line passing through horizon. If passing through horizon means no doubt it makes some angles, alpha, beta, gamma with x, y, z, isn't it? The parallel lines are having the same angles, alpha, beta, gamma. Suppose it is wherever maybe in the space, no doubt that line makes some angles with x, y, z. How can we say parallel to that line through horizon? If you draw, these two lines are parallel, original line and a parallel line. Okay now. Passing through horizon means no doubt they are making some angles, alpha, beta, gamma. Then cos alpha, cos beta, cos gamma with the DCs. So for any line in the space, there must be DCs. So the sum of DCs, the sum of squares of DCs, okay now, is always 1, unity 1. It is a very good concept. It is a theorem. It's a very fine theorem. Okay now. So it is the first theorem we assume. Okay? Right. Here only I want to tell one more thing. Second part. As we know, L square plus m square plus n square is equal to 1r. Sum of squares of the DCs of any line, L square plus m square plus n is equal to 1. That means cos square alpha, cos square beta, cos square gamma is equal to 1. Directly, the 2 marks or the 3 marks, this type of question is asked. Show that cos square alpha plus cos square beta plus cos square gamma is equal to 1, just like already we proved. Now the second, show that sin square alpha plus sin square beta plus sin square gamma is equal to 2. Are taking LHS. What is sin square alpha plus sin square beta plus sin square gamma? I am taking LHS. It is 1 minus cos square alpha, 1 minus cos square beta, 1 minus cos square gamma. We write from the trigonometry. This is the okay now. So 1 minus cos square alpha, 1 plus 1. So this is 3 minus of cos square alpha plus cos square beta plus cos square gamma. I am taking all cos's at one place, taking minus as common. So this is 3. We know it is 1. Okay, now so it is 2. That is equal to RHS. The first question is, show that cos square alpha plus cos square beta plus cos square gamma is equal to 1. The second question is sin square alpha plus sin square beta plus sin square gamma is equal to 2. Already going forward. Okay, now these are the two concepts. Very good concept. Already these questions are asked in the previous papers. Yeah, pass. Right. Now, the next concept is direction ratios. Also, it is taught in the vectors. Direction cosines over, now direction ratios. But you have to know by heart, learn the definition also. What are direction ratios? L, M, N are the DCs of any line OP. Then not only OP, OA or AB or LM, something, any line. For that line, L, M, N are the DCs. Then a set of three numbers which are proportional to these DCs, L, M, N, are called means those three numbers are called as direction ratios. Direction ratios. Okay now? Generally, those direction ratios denoted by A, B, C. L, M, N are the DCs, A, B, C are the DRs. These are called as the DRs. Okay then? So DRs, direction ratios means is a triplet, a set of three numbers which are proportional to those cos alpha, cos beta, cos gamma, or otherwise L, M, N, or otherwise DCs. Okay, no? Right. Those numbers are called as DRs. That means they are proportional means L by A, M by B, N by C are in the same ratio. That is from the definition we get that one. L by A is, M by B is, N by C is equal to some K. Again, all are equal to this K. L is equal to AK, M is equal to BK, N is equal to CK. Okay, now, right. Come this way. As we know already, the previous, we solved this one. L square plus M square plus M square is equal to 1. The sum of squares of the DCs of any line is L square plus M square plus M square is equal to 1. Cos square alpha plus cos square beta plus cos square gamma is equal to 1. We know each one. Just now we solved that theorem. The sum of squares of DCs of any line is always unity, 1. L square plus M square plus M square is equal to 1. What is L? AK whole square. That is A square K square. What is M? BK. BK whole square. B square K square. What is N? CK. C square K square is equal to 1. Okay, that one N. Instead of N square, I wrote C square K square is equal to total is 1. In that theorem, in that statement, I am using this concept. We are taking K square as common. So, A square plus B square plus C square is there. Is equal to 1 as this 1 is coming. So, K square is equal to 1 by this sum of squares of those DRs. A square plus B square plus C square. So, K is equal to total root. Root means root 1 is root same 1. This root is there okay, na? But you mentioned plus or minus for this one. Why? Because from square we are getting K is equal to 1 by root of A square plus B square plus C square. Is okay na? Yeah. So this is K value. What is K? We are taking a scalar, a constant. It is a constant. Any constant, arbitrary value, constant. Now, you see that. Now, what is L? AK na? That means A by A. A into K means 1 by something. So, we may write here now. This is our L, M, L. What is L? It is AK. AK means AK, this is BK, this is CK. What is A? K. K is plus or minus. It is A square plus B square plus C square. And B by, it is also A square plus B square plus C square. C by, it is A square plus B square plus C square. Okay now, this is the relation. It is a very good concept. It is a relation between this is and drs. Okay now, of any line. If a line is there, no doubt. Line segment is there, a beam is there. No doubt, drs and dcs are there. But what is the relation means? If you know the drs, we can find the dcs. That is the concept. First we learn dcs. Through that one we can get drs. But in the problems, we are given first drs one. Through that one we can find the dcs. If a comma b comma c are the drs, then what are the dcs means? How can you calculate LMN means a by the sum of squares of that drs. A by B by C by. Okay na? That is the relation. Yeah. Is it okay? So, direction cosines, direction ratios, don't confuse. Direction cosines means it's simply, if anybody asks you that what is the drs and dcs? Suppose P is a point. OP line makes alpha, beta, gamma with x, y, z axis. Then cos alpha, cos beta, cos gamma are the DCs. They are direction cosines. LMN, their notation. Then what about drs means? Drs is nothing but a set of three numbers which are proportional to the cosines, direction cosines, which are generally denoted by A comma B comma C. Okay, Nina? That is the thing. Yeah, okay. Bye.